Hello, we're back again. This is part 3 now, just finishing up Learning Guide 14. Now we're going to deal with those conjugates I talked about earlier. And remember when I said you have a 1 plus C and then on the other side on the top you have a 1 minus C? That situation sort of triggers a conjugate to be done. So let's do our steps here, changing things to S's and C's. So here we have S, 1 plus C. Can't do anything. We can't factor. We can't do complex fractions or anything. So we're stuck there. Now we're here. And again, we can't do anything. So to prove this identity, we use the conjugate. Okay, the conjugate is going to be 1 minus C. What you do to the bottom, you must do to the top. You don't have to go to the other side, so just deal with the left side only. Now, when you rainbow this, and we get 1 minus C squared, because the middle ones cancel out because a plus C and a minus C. That's part of that conjugating. And on the top you have S and 1 minus C. So don't rainbow this S in. Just leave it as an S because you'll see something happen. So now when you see this guy right here, you have to realize it's one of your Pythagoras identities. So we remember that, and we can look on your formula sheet. This guy becomes S squared. All right, and then we have the S and the 1 minus C. Now you probably notice that this S takes off that S, and now we're left with 1 minus C over S, and there is that identity. Okay, so I want you guys to try these ones on the bottom. You can pause and check the answers. So on number 3 here, I'll just let you know that there's 2 ways you can approach this. This is cos 2x if you look on your formula sheet, and so is this. Or you can prove it through, when I look on this side over here, I see an S, so I'm going to get rid of this guy. And remember, that c squared is 1 minus s squared minus s squared. These guys are like terms, so it's 1 minus 2s squared. So you can approach it two different ways there. All right, on this last few, let's do this. And this last one, there are situations where they cannot be done, and this is a situation that this and this do not equal. All right, and sometimes it's easier to check by graphing. So you can graph, and if they don't overlap each other, then you know they're not identical. So, or you can plug in a value for x. Like, we can make it pi over 2 and check it that